All right, this is the topic for review. So number one here is asking us to write a triangle congruence statement for the two triangles on the right. So you just want to name that first triangle however you want. There's 6 different ways we could name it. Triangle CAR, triangle CRA, triangle RCA, triangle RAC, triangle ARC, or triangle ACR. I'm just going to do triangle CAR. Okay, again, 6 different ways you can name it though. But then when you name the second one, you have to match up the corresponding parts. So C here is between the 1 hash mark and the 2 hash marks. So C is going to correspond with G. So we got to put triangle G. All right, A is between the 1 and the 3. So A is going to correspond with E. And then R is between the 2 and the 3. So R is going to correspond with O. Okay, if you picked a different triangle, that would be fine. So if we called it triangle RCA, for example, we would just have to match up those pieces, those corresponding vertices. So R would match up with O, C would match up with G, and then A would match up with E. So pretty simple there. And again, on the test, it'll be multiple choice, so you're really just picking the one that works. Okay, 2 here. Again, you'll have a multiple choice question, I guess, on the test, and it'll ask you which theorem doesn't work, right? So we got to know which theorems do work. So it's asking us to list the 5 theorems we have, or the 5 shortcuts for proving triangles are congruent. So we have side, side, side. We have side, angle, side. We have angle, side, angle. We have angle, angle, side. And we have HL. Okay, and the 2 that don't work are going to be angle, angle, angle. Right, that's not sufficient information. And then again, angle, side, side. Okay, so these are the 5 that work. Those are the 2 that don't. You can also write angle, side, side, right? That could also be written as side, side, angle. Right, doesn't work. Okay, number 3 wants us to choose to determine which theorem is going to prove the triangles are congruent. So in A here, we have 2 pair of angles and 1 pair of sides. That pair of sides is between those 2 pair of angles. So we're going to have angle, side, angle. All right, this is an angle, that's a side, that's an angle. Okay. B, you can use the reflexive property, right? We can't add anything to these diagrams, but we can add things that we know are we're 100% certain of. So we're 100% certain that we have a shared side here, which means by the reflexive property, it's going to be the same for both triangles. The length of this diagonal here is going to be the same for the triangle on the left as it is for the triangle on the right. It'll be the same length. So now we have angle, angle, side. Right, 2 pair of angles, 1 pair of sides. The side is not between the 2 angles, so it's angle, angle, side. Okay, here we have 1 pair of angles and 1 pair of sides, but we also have vertical angles, so we can fill in our vertical angles. We know vertical angles are always congruent, so we can add those. Right, and then you have angle, side, angle, angle, side, angle. Okay. This one over here, we can use the reflexive property again. We have a shared side. So we know that this diagonal in the middle is the same length for both triangles, so it's congruent to itself, right? So we can add the 3 hash marks there. Okay. The other thing is if we know 2 angles of a triangle, we know the third angle. So if we have 2 angles in this triangle are congruent to 2 angles of this triangle, then they're going to be congruent. The third pair of angles will also be congruent, right? So if this was like 90 and this was 50, this would have to be 90 and 50, which means these would have to be 40 and 40. So whatever these are, it doesn't matter what they are. We just know 2 pair of angles are congruent. We know that third pair is also going to be congruent. So in reality here, we could use any of the theorems. We could use side, angle, side, 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 angle, angle, side, or we could use HL. We have a right triangle, we have hypotenuse congruent, and a pair of legs. So any of them are going to work. I'm just going to do side, 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 because I think that's the easiest one. Okay. In E here, we have 3 pair of sides congruent, so that's going to be side, side, side. Okay. F, we have a right angle here, so we know this side's a right angle as well. We can use the reflexive property again. So if we tried this one with our angle and sides, we would have angle, side, side, which again is one of the ones that doesn't work. So we want to abandon that. But we do have a right angle, so we want to try HL. So HL, again, there are 3 criteria. You need right triangles. We have right triangles. These right angles tell us those 2 triangles are right triangles. We have the hypotenuses here congruent, right? The hypotenuses are the side across from the right angle. And then we have a pair of legs congruent, so that's going to work. We can use HL. Right, G, we can use the reflexive property. Okay, but there's nothing else we can add. So that we just have 2 pair of sides, so that's not going to be enough information. So we'll say not possible. They look congruent, maybe they're congruent, we're just not sure. There's not enough information. Okay, H here, we have a right angle, and then the hypotenuses are congruent, but they don't give us any information about any other angles or the legs or anything like that. So this one we don't have enough information. We again have to say not possible. I, we have vertical angles. Okay, so we can add the vertical angles in. We know vertical angles are always congruent. And then we have side, angle, side. Side, angle, side. Okay, and then this one here, we have angle, angle, side. 2 pair of angles, 1 pair of sides. The sides are not included. They're not between the 2 angles. So it's angle, angle, side. All right, number 4 here. Can we easily draw lines on this? Okay, so it says the congruent thing cut off for some reason here, but it should be AD is congruent to BC. So AD, not the drawing tool here. So AD is congruent to BC, so we can mark those in. And then AB is congruent to DC. Okay, and we're trying to show that triangle ABC. Oh, we want a different color though. Right triangle ABC here is congruent to triangle CDA. So C, D, and then A. Right, so we can use then the reflexive property. Right, AC is going to be congruent to AC. So now we have side, side, side. These 2 triangles would be congruent by side, side, side. Right, they gave us 2 pair of sides, and then we know here AC is congruent in both of the purple triangles that we're trying to look at. ABC, triangle ABC, and triangle CDA. So side, side, side. Right. That's the easiest one of these, I think. So let's look at the next one. Okay, it says AC and BD bisect each other, and then we want to know what theorem proves that ADM is congruent to triangles ADM is congruent to triangles CBM. So let's look here. If we have AC and BD, so here's AC, maybe in green here we'll do BD. Okay, it's saying that they bisect each other. So if something bisects something else, that means it splits it in half. It splits into two congruent pieces. So if AC is going to split BD here in half, so if the red line splits the green line in half, we know that MD is going to be congruent to MB. Okay, and it says they bisect each other, so BD also bisects AC. So BD, here the green line, will also bisect AC. So the green line is going to split that red line in half. So AM and CM are going to be congruent. Okay, and we're trying to prove that triangle ADM, that's this triangle here, is congruent to triangle CBM, which is this purple triangle here. So we can add vertical angles here. Right, we know vertical angles are congruent. And then we have side, angle, side. So then we have side, angle, side. All right, so those two triangles, ADM and CBM, are congruent by side, angle, side. We have AC and BD bisect each other, so we know that MD and MB are congruent, as well as AM and CD. And then you add your vertical angles in, and then you have side, angle, side. Those two triangles are congruent. Okay, the third one. If AD is congruent to BC, and then AD is parallel to BC. So let me draw those in. So we'll draw it as a full line. AD is parallel to BC. Okay, I'm going to put little arrows on this to tell us that they're parallel. Okay, and then what theorem proves triangle ADB is congruent to triangle CBD. So let's highlight those triangles, I think would be helpful. So here's ADB. And then CDB would be this triangle here. So we want to show that these two triangles here are congruent. Okay. All right. So let's use the parallel lines piece. So, or maybe in red. All right. So if we look at our, well, we have two transversals here. Okay. But let's pick this one because that's going to give us the angles we want, right? So if you have parallel lines, you're looking for angles. Okay. So here's your parallel lines. And then you got your transversal. So your alternate interior angles, and we want those angles to be angles in the triangle, right? That's why we're picking this as our transversal, right? DB is our transversal instead of AC. Because if you used AC as your transversal, you're only going to get a piece of these two angles here. We want to show that the whole angle is congruent, so that's why we're picking DB. So therefore, we got this angle here, ADM. Angle ADM would be congruent to angle CBM. Okay. And then that's one pair of angles, one pair of sides. Okay, the last thing then is we can use the reflexive property here, right, to show that DB is congruent to DB. And now you have side, angle, side. Right, so we knew they told us segment AD was congruent to segment BC. Okay, since the lines are parallel, our alternate interior angles here are congruent. And then we have a shared side, so we use the reflexive property. So then we have two pair of sides, one pair of angle, and then it's side, angle, side. Those two triangles are congruent. All right, let's try the last one here. Okay, M is the midpoint of AC. So here's AC. If M is the midpoint, that means M is in the middle. That means each side, AM and MC, are going to be congruent. right? The middle. So it's like the bisector, right? It splits it in half. Okay. And then AD is parallel to BC. So again, we have AD here being parallel to BC. Okay, and this time we're trying to show that triangle ADM, so this triangle here, is congruent to triangle CBM. Okay. There's actually two different ways we can do this one then, depending on what you choose as your transversal. So if we're going to make AC our transversal, right? So our purple lines are the parallel lines. AC here is our transversal. Our alternate interior angles are going to be congruent. So that means angle ADM is going to be congruent to angle BCM. Okay. And you can then also use the other one as your transversal. So if we made DB our transversal, then we'd have angle ADM here would be congruent to CBM, right? Alternate interior angles. These two pairs of angles would be congruent because of the alternate interior angle theorem. If you have parallel lines, the alternate interior angles are congruent. Okay. The other thing you can do is you do have vertical angles, so you can also fill in vertical angles. Okay. So now we can either use angle side, or we can use angle side angle, whichever one you want to use there. So angle side, or get this out of the way, not expand it. Oops. Yeah, just move it. Or angle side angle. Okay. All right, moving on to number 5 here. It says, what additional information is needed to prove the triangles are are congruent by the indicated postulate? So for A, we want to show, they're asking us what additional information do they need to give us in order to use angle side. Okay. Well, they give us one pair of angles and one pair of sides. Right? And since we want angle side, we need another pair of angles. Okay. If we picked angle F and angle J, we would then have angle side angle. So we don't want angle side angle, we want angle side. So we have to pick the angle so that side is not in the middle. So we're going to have to choose the other pair of angles, angle G and angle L. So we're going to have to say angle G is congruent to angle L. So again, the question is, what additional information would they have to provide for us? They give us one pair of angles, one pair of sides. They would need to give us another pair of angles, and that pair of angles would have to be angle L and angle G. Okay, for this one, we know SQ is congruent to QS, right? Again, that's technically the symmetric property, but we're always just going to call it reflexive. SQ is congruent to SQ. All right. So that's one pair of angles, one pair of sides. Okay. So they want us to use HL to show that these two triangles are congruent. So HL, you need right triangles. We have two right angles. That's giving us right triangles. SQ is the hypotenuse for each of these two triangles. So hypotenuses are good. And then the third thing is we need a pair of legs. So in order to prove these are congruent by HL, we would need a pair of legs to be congruent. So that means PS has to be congruent to QR. They would have to tell us that segment PS is congruent to segment RQ. Okay, or they could tell us that segment PQ is congruent to segment RS. They would have to give us one of the pair of legs. They would have to tell us one of those pairs of legs are congruent. Okay, C here, we can fill in vertical angles. We know vertical angles are congruent 100% of the time. Okay, they want us to use angle side angle. We have two pair of angles that are congruent then. So they would have to give us a pair of sides that were congruent. And that pair of sides would have to be between the two angles. It'd have to be the included side. So that's going to have to be WX and ZX. So they would have to tell us that segment WX is congruent to segment ZX. Okay, so that's the additional information problems. All right, 6 here, given that triangle DCE and ABC are isosceles. So we know that these are isosceles triangles. All right, the big one and then the inside one. We can probably highlight them too if you, we'll do the inside one here in blue. All right, that light blue one's an isosceles triangle. And then the large one, this orangish color, maybe. You can trace the line, good. Okay. So two isosceles triangles there. Given that segment CF is perpendicular to and bisects segment DE. Okay, so perpendicular to, so we have put in our right angles if CF is perpendicular to DE. Okay, and then it also says that it bisects the bottom here. So DF is going to be congruent to FE. Okay, the measure of angle BCF, so that's this angle here, is 20 degrees. So this angle here is 20 degrees. Okay. You could actually use the reflexive property here. Okay, so these two triangles are congruent. So if this is 20 degrees, this is also going to be 20 degrees. Okay. And then we can find the third angle of that triangle. Right, so the third angle of this triangle, that's going to be 180, right, minus 90 minus 20. Right, the right angle is 90 degrees, and then you have a 20-degree angle. So that's 110. So 180 minus 110 is going to give us 70. So the measure of angle 2 is going to be 70. And the measure of angle 3 is also going to be 70. Okay, and then you have linear pairs. Right, we have a linear pair here. So linear pairs are supplementary. So 180 minus 70 is going to give us 110. So this is 110. And then this is 110. Okay, so fairly straightforward there. So the measure of angle 1 is 70. I'm sorry, the measure of angle 1 is 110. Oh, what I hit? Yeah, so measure 70. 2 and 3 then are, I'm sorry, 110. And then 70, 70, and then 110. Okay. All right. 7 here. So we want to know the perimeter. So the perimeter is the distance around the figure. So the perimeter would be AB plus AC plus BC. Right? Those three sides added together. So if we look, let's just fill in our sides then. Okay. So if this is 10, right, it's got the 1 hash mark. We know this is 10. And we know this is 10. Okay. If we notice here, we have a 60-degree angle, and it's isosceles, right? This triangle is isosceles. So this would have to be 60. Okay, but then if we did 180 minus 60 minus 60, right, that's going to be 180 minus 120 is 60. So this one here is actually an equilateral triangle. So if that's 10 and that's 10, this is also going to be 10. Okay, and then so if we're finding the perimeter here, all right, we're going to do 10 plus 10 is 20 plus 18. Right, which is 38 plus 10 is going to be 48. So your perimeter is going to be 10, right, plus 10 plus 18 plus 10, which is going to give you 48. Right, 10 plus 10 plus 18 plus 10. Right, this 10 is not part of your perimeter. Okay. If we're dealing with the angles here then, so we have 60. Maybe I should do the angles in black. Okay, right, so we determined if that's 60, and since it's isosceles, this one is 60 as well, which means it's actually equilateral because it's going to be 60, 60, and the third angle has to be 60 as well. Okay. So again, the three most common things you look for on these are vertical angles, linear pairs, and the three angles of a triangle add up to 180. So we just used the fact that the three angles of a triangle added up to 180 to get 60 here. And then if we notice we have a linear pair, so we can do 180 minus 60, and that's going to be 120. So this angle here is 120. Okay. And then you have another isosceles triangle here. So we can do 180 minus 120, which is 60. Okay. So we know these two angles here are congruent. Angle DBC and angle C are congruent, and they have to add up to 60. So we're going to divide this by 2, and that's going to give us 30. So these two angles here would be 30 and 30. Okay, so what is the measure of angle C? It's going to be 30 degrees. Okay, so again, just to recap, since this is 60, we know that, and it's isosceles, we know that this is also 60, which told us that this third angle also had to be 60, because 180 minus 60 gives us 60. So this actually has to be an equilateral triangle. Okay, we have a linear pair here, so 180 minus 60 gives us 120. And then we have another isosceles triangle up here. So for this triangle, we do 180 minus 120. That gives us 60. So these two angles have to add up to 60. And since it's isosceles, those base angles are congruent. So they add up to 60 and they're congruent. So we divide by 2 and you get 30 and 30. Okay, for the perimeter, again, since this ended up being equilateral, well, since this was isosceles, since this is 10 here, this is also 10. And since this is equilateral, these become 10 and 10. Right? And then if you're finding the perimeter of this figure of triangle ABC, we just add up the pieces on the outside. 10 plus 10 plus 10 plus 18. Right? And you don't add this piece, right? Because that's not part of the perimeter. 10 plus 10 plus 10 plus 18. 48. Right? And number 8's asking the same thing here. So let's start with the perimeter. Right? So this is 5 here. Right? So this is isosceles, so it says this is 5 as well. And then this one here is also isosceles, so since that's 5, this is 5. Okay, and then for our perimeter, we just add up whatever's on the outside. So we're going to do 5 plus 9 plus 6. So 5 plus 9 plus 6. So the perimeter of triangle PRQ there is going to be, that's 19 plus 6 is going to be 25. Measure of angle P, so we want to try and get over here to P. Okay, so this is an isosceles triangle, so this is going to be 40. Okay, three angles of a triangle add up to 180, right? Those two are congruent. So we can do 180 minus 40 minus 40. That's 180 minus 80, so that's going to be 100. Right. So again, the three most common things: vertical angles are congruent, linear pairs are supplementary, and the three angles of a triangle add up to 180. So here we use the fact that the three angles of the triangle added up to 180. And so we got the measure of angle QSR is 100. We then have a linear pair, so we can do 180 minus 100, which is going to be 80. So this is 80 degrees. Okay, and then we have another isosceles triangle. So we know that angle Q here, or angle PQS, is going to be congruent to angle P. All right. So if we do 180 minus 80, that is 100. So we know those two angles are congruent. We also know they add up to 100. So if we divide by 2, that's going to be 50 and 50. So 50 here plus 50 plus 80 is going to be 180. So the measure of angle P is 50 degrees. Okay. So that's number 7 and 8, perimeter and angle measures. All right. Okay, and then we got some more complex diagrams here. All right. So which theorem shows that triangle ABC is congruent to triangle DEF? So let's highlight those first. So here's triangle ABC. Okay, and then triangle DEF would be this one. Okay, so those are our two triangles. Okay. If we notice here, we got one pair of sides. Okay, we have right angles here. So those are given. We have a right angle and then that pair of sides. So we need to add a third piece of information. If we look here at this triangle, right, this is an isosceles triangle. So we know the base angles are congruent. So I know that angle GFC is congruent to angle GCF. Okay, and then if we look at those two red triangles, we now have angle, angle, side, right? Angle, angle, side. So those two triangles would be congruent by angle, angle, side. Remember, we can't add anything we want, right? AC and FD, the hypotenuses there, they look congruent, but we can't just add them. We have to be 100% sure. We need a postulate, theorem, or reason to be able to add it. So the one we can add here is we knew that this small triangle was isosceles, so we knew that those two base angles were congruent, so we can use angle, angle, side. Okay. The next question asks us to name all four pairs of congruent triangles. So we have the first one, triangle ABC was congruent to triangle DEF. Okay, that was by angle, angle, side. Okay, and if we want to name the other ones, let's pick a different color. So let's do right. So the idea here is once you know that the triangles are congruent, you know their corresponding parts are congruent. So we now know that AC here, right, is congruent to FD. You know these angles are congruent as well. So we can name the other triangles here. So it's basically going to be BF, right? This triangle here is going to be congruent to this one here, right? And again, if you wanted to say why, I guess one way we could do it, we know FC is congruent to FC, right? Okay, and we know that, right, if you want to do a little segment addition, right, EF is equal to EC plus CF, right? And we know that BC is equal to EC, I'm sorry, BF, what did I put, EC? Yeah, so BF plus CF, okay? Since we know those two red triangles are congruent, right, ABC and DEF, we know that EF is equal to BC, right? EF is, segment EF is congruent to segment BC, so those lengths are equal. So we can use the transitive property and say EC plus CF is equal to BF. And you don't have, I mean, you don't have to write all this out, obviously. I'm just trying to show it to you if you're curious. Okay, right? And then you subtract CF from both sides and you get EC equals BC or equals BF. So you know that those two pieces here are congruent. So then you would have side, angle, side, right? It's not asking you why, it's just telling you to list the congruent triangles. So you don't need to do all that. But ABF would be congruent to triangle DEC. Okay. So then again, all their corresponding parts are going to be congruent, right? So we know all their corresponding parts are congruent as well. Okay. And then if we look here at these big ones here, right? We know that, well, there's an angle there and an angle here. Right? We know that these sides are congruent, right? Because of the purple triangles. So I'm running out of letters here, but 1, 2, 3, 4, 5. Right? 1, 2, 3, 4, 5. Right? Since the purple triangles are congruent, their corresponding parts are congruent. So we know CD is congruent to EF. So that gives us side, side. And then since the red triangles are congruent, we know that I'm just going to put a V1 here and then a V1. Right? We know that AC is congruent to FD. So you can use side, side, side to show that those two triangles are congruent. Triangle AFC would be congruent to triangle DCF. Okay, right. So FC is congruent to FC, reflexive property. Since the purple triangles are congruent, we know that FA is congruent to CD. And since the red triangles are congruent, we know that AC is congruent to FD. Okay, and then the last pair of triangles here, I don't know, pink. Okay, these two triangles here in pink. Okay. I guess we have two pair of sides there. We can just use, I mean, there's so many different ways we could do this. Whoops, didn't want to do that. Right. I guess the easiest way is just to say, so since FG and CF are congruent, and we know AC is congruent to DC, again, we can do this again and find that AG here. So V11, AG would be congruent to GD, right? So we know AC, right, would be AG plus GC, right? And then we know that DF here is going to be GD plus FG, right? We know these are equal to each other, right? So we know AG plus GC equals GD plus GF. What did I put as an FG? Yeah, I should have wrote it as GF instead of FG, GF. That's all right. Doesn't matter either way. Okay, and then we also know that FG here is congruent to CG. So we know those are equal. So when we subtract those away, and then we have AG is equal to GD. So then we have side, side, side. So triangle AGF would be congruent to triangle GGC. Okay, so those would be all your congruent triangles. I don't think I made it, by showing you all, you don't need to do all that. I was just trying to show you where and why everything is congruent. Okay. All right, last one then, number 10. Okay. Which theorem shows that triangle ETF here is congruent to triangle EKF? And explain. So for these, there's lots of different ways to do them. So that's why the explain part is there. I think the easiest way to do this one, though, is you can just use the reflexive property here. Right, so reflexive property. Right, and now those two triangles, ETF and EKF, are congruent by side, side, side. We use the reflexive property and have side, side, side. Okay. B. Okay, says which theorem shows that triangle STF? Definitely don't want to use black there. Let's pick a better color. STF and SKF. Okay. So we know that this is a right angle, right? If this one's a right angle here, that means that KT and EF are perpendicular, so we know we have a right angle here as well. Okay, and then we can use the reflexive property here, right? SF is congruent to SF. If we try to use our angle and sides, we would have angle side side, and we know angle side side doesn't work, right? But since it's a right angle, we can try HL. So we have two right triangles, so check. And then the H part, the hypotenuses here are congruent, so that's a check. And then the SF is a leg for both triangles, so we have a pair of legs that's congruent. So we can use HL. Right? Two right triangles, hypotenuse, pair of hypotenuses congruent, one of the pair of legs is congruent. So we can use HL to say that those two triangles are congruent. They have to be the same size and shape. Okay, and then the last one here, which theorem tells us ESK is congruent to EST. ESK is congruent to EST. Okay, again, this will be the same thing, right? You can use the reflexive property. Since this is a right angle here, right, that means KT and EF are perpendicular. So you have right angles all the way around. So these two angles, angle ESK and angle EST, are right angles. So once again, we have right angles that are congruent, right? So we have two right triangles. Hypotenuses are congruent. And then we have a pair of legs. So once again, we're going to use HL. Okay. Yep. All right, and that's I think that's it. So if you can do everything on here, you should absolutely ace the test. The test will be easier than the review, I hope.